Well, now we calculate F value and compare it with the F critical value to determine by the degree of freedoms of the problem. Now, what is degree of freedom? Understand this concept very clearly, because each and every step of ANOVA we should use this concept of degree of freedom. Even chi-square analysis also we used this concept degree of freedom. Now, what is degree of freedom? That means the freedom which you have to choose the options. Now, let's take an example that I am telling you. You make 100 total, you know, choosing for any numbers you choose, and you make the total in total, so that it happens 100. So it may be possible first option you are choosing 20, second option is 30, third option you have chosen 15. What will be the fourth option then? Definitely what you are going to do, 100 minus 20, 30, 50, 50 plus 15, 65. So last option definitely you will choose 35, because the condition is it will not exceed 100 or it will not be lesser than 100, right? So if you see in a different manner, that as I told that you select any four numbers to create 100, what you are doing, first option is you are free to choose, second option is you are free to choose, third option you are free to choose, but fourth option, no, you are not free to choose, you are bound. So that means the degree of freedom is nothing but not the four options or four choices, whatever you are having. It is 4 minus 1, which is 3. Similarly, if I say that you select five numbers and make it 100, it will be considered as, instead of five options, you will have the proper degree of freedom 5 minus 1, which is 4. Clear? Now, if you have understood that concept, consider another concept which is generally used in our mathematical or statistical problems. Okay, so we are having this kind of table everywhere. Think that this is the row is denoted by n and columns are denoted by k. Example, so you can do a name whatsoever. So in this case you are having 1, 2 and 3 columns, and you are having, let's say I'm just giving example, 4 rows. Okay, to reduce the complexity and the ambiguity. So let's say 1, 2, 3 and 4. So what you are having, you are having 4 rows and you are having 3 columns. Now in that case, what will be the degree of freedom? Same way, if you start from here, if you start from here and you start traveling here, what will happen? You are having total number of columns, first column, second column, third column, right? So you will have 3 minus 1, that is 2, which will be the degree of freedom of columns. Similarly, in case of n equals to 4, the degree of freedom of row will be nothing but 4 minus 1 equals to 3. Clear? And the total degree of freedom of this will be nothing but 3 minus 1 multiplied by 4 minus 1. That means column minus 1 multiplied by row minus 1. So in that case I can easily write maybe k minus 1 multiplied by n minus 1. Is it clear? So the total degree of freedom for this particular given table will be k minus 1 multiplied by n minus 1. But if it is not given as a table format and all, only column or only rows, then we will use this concept. Now this degree of freedom is applicable when we are talking about the chi-square test. Chi-square test. That means in chi-square test, we'll consider if we are getting this kind of table wherein there are 4 rows and 3 columns, the degree of freedom for chi-square test to be considered is k minus 1 multiplied by n minus 1. Now, what is all about the ANOVA? So when the moment I'm talking about the ANOVA, we have two types of degree of freedom. Degree of freedom of numerator, which is nothing but degree of freedom of column, and another is degree of freedom of denominator, which is nothing but degree of freedom of row. So now this is a slightly different formula than to the chi-square test. For ANOVA, degree of freedom of numerator is nothing but which is degree of freedom of the column is denoted by k minus 1. Okay, so the k minus 1, yes, it is same. Okay, there is no doubt on that. In this case, there are 3 columns, 1, 2, 3. So the degree of freedom dfn numerator is 3 minus 1 equals to 2 in case of ANOVA. And degree of freedom of denominator, which is DFR, is denoted by NT minus K. Now what is NT? NT is total sample size. Now herein if you see, the total sample size is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So total 12 samples you are having here, and total number of groups, this is number of groups we are talking about. Okay, or we can say number of groups or columns, both in both the way, both are the same. So we are having the groups one, first group, second group and third group, or column 1, column 2 and column 3. So minus 3, which is equals to 9. So that means based on this two value, degree of freedom n and degree of freedom of 9, we can calculate the critical value based on the F distribution table. Okay, and herein based on this degree of freedom and the alpha 0.05 whatever, we can refer the chi-square table and can find out the value. Herein we refer the F distribution table and can find out the F critical value. Hope you have understood the concept of degree of freedom, how we apply this degree of freedom in chi-square test and ANOVA, and how it is different in terms of calculation.